Which AI model should I use? The answer depends on the task and the output you want. Is this web research, code, analysis of a technical document? Do you want a few ideas, a finished deliverable, or a fully formed action plan? Those are different jobs, and they may need different models. 662. That's how many work orders my system completed in the last 30 days. Not prompts, not tokens. 662 completed unique work orders, each one routed, verified, and closed. That's the data set. That question assumes the answer is singular, one model for all the work. But the system that completed 662 jobs used different models for different job types. The answer was never one, it was always an allocation. Here's what those work orders actually did. Software and video game engineering, model testing and qualification, image, video production and processing, text document review and extraction, web research, business document review and production, plus processing and indexing my continuous output. 30 days, July 23rd through August 21st, 2026, 662 completed unique work orders routed to named operational seats. Before reading the bars, one clarification. These counts are completed unique work orders. They're not tokens consumed, not intelligence scores, not leaderboard rankings. Routing labels describe the seat the job was sent to, inside this specific 30-day window, nothing else. The labels on the chart, Sonnet, Terra, Sol, Opus, those are operational seat names. They describe positions in the workflow during this 30-day period, not timeless claims about which vendor outperforms which. A job is a bounded contract. To understand the allocation, you need to understand what a job is. A job is a bounded contract, a defined input, a defined output, a verifier that confirms the work is done, and an escalation path. Here's one example. Input, a data file and a target schema. Expected output, a validated manifest. Verifier, deterministic hash check. The model gets credit only when the hash passes. If the hash fails, the work escalates, it's not abandoned. The system does not mark a job complete when a model produces output. It marks it complete when the verifier passes. Failed work does not disappear. It comes back as a bounded residue for the next worker. Now, for part most people overlook, a model is not equivalent to a worker. The same model in two different seats, different authority, different tools, different return contract. That's two different workers. Seat dimensions. A seat has 6 properties: the authority the worker holds, the context it can access, the tools it can invoke, the verifier that defines what done means, the failure cost if it's wrong, and the latency budget it is allowed. So worker is model plus seat plus verifier. The complete identity of a worker is the model, the seat, and the verifier together. Unspecify any one of those, and you've picked a component, not a machine. The model is the component, the workflow is the machine. Look at the chart by tier. Sonnet and Terra together handled 477 of the 662 work orders, more than 70%. The majority of production work is bounded construction, processing, testing, and documentation. Sol and Opus together handled 80 work orders, 12% of the total. Apex reasoning is expensive. The architecture reserves it for unresolved synthesis, consequential judgment, and coordination decisions. The remaining bars cover the deterministic, local, and catch-all seats, work with known algorithms, schema validation, repeatable transforms that conventional software handles without a language model. The system as a whole. Step back from the individual bars. This chart is an allocation record across one frozen 30-day window. July 23rd through August 21st, 2026 of my system and the work that I happen to be performing at that time. It's not a ranking, we're not picking winners or favorite models here. Think about how you choose a vehicle. You don't pick your daily commuter by top track speed or by maximum towing capacity, unless you need those things on your daily commute. You look at what the job demands, the route, the load, the conditions. Just like a car, you want a vehicle that gets you there safely, accurately, for the least fuel. So the operational question is, what gets this declared job from its starting state to an acceptable result, safely, accurately, and with the least compute? That's how model selection works. Specify the job before you name the model. Here's one routing example. It starts at the apex. An apex worker receives an open-ended specification, returns a bounded system definition, input contracts, output contracts, and acceptance tests. That definition is what flows downstream. That definition goes to the builder tier. Two workers implement parallel components against the declared contracts independently, each returning output to the verifier. The verifier is deterministic. It runs schemas, checks hashes, and replays fixtures. These are binary pass-fail operations a conventional program runs without a language model. Anything that fails comes back as bounded residue. The apex worker does not receive a vague retry, it receives a specific constrained failure, the exact delta between the actual output and the acceptance test. It resolves the delta and closes the work. Here's what you can use today. Before you route your next task to a model, write down 5 things. Not in a new tool, just in a note. The structure is the discipline. First, the job. What specifically needs to happen? Second, the completion test. How will you know the work is done? Third, the failure cost. What goes wrong if the output is wrong? Fourth, cheapest plausible model for the specific task. And fifth, the escalation route. The model is not the system. The allocation is the system. The question is not which model you should use. The question is, which job are you routing to what seat with what verifier? So what task are you currently forcing through one Apex model that probably wants its own seat? Leave it in the comments. That question gives you the architecture for your next workflow and maybe gives me the topic for my next video. I'm TJ Young with HMIC. This is the assembled work.